Good day. Welcome to Air Pollution 7.1. So a little review on the atmosphere. Remember that most of our atmosphere consists of N2 nitrogen, and then if you average it out, about 21% is oxygen. We do have other gases in the atmosphere, argon. There is carbon dioxide naturally, 0.04%. And as you can see, a little bit of other gases and some water vapor between 0 and 4%, depending on the humidity and where we are located, and looking at that level. Also, please recall that the atmosphere has layers. So we live in the troposphere. Most of the water, all of the weather happens at this layer. And then as we rise up, the stratosphere is formed, and the important part about the stratosphere is it's got the ozone layer, which this is the layer that blocks harmful UV radiation. And then we've got the mesosphere. That one's famous for dissolving a lot of the meteors. And the thermosphere is where we get those beautiful aurora borealis lights. And remember, the tropopause, as we get higher, the temperature gets lower. The stratosphere, as you go up in altitude, the temperature gets higher. So it's kind of every other. The mesosphere, as you go up, temperature goes down. And the thermosphere, as you go up, the temperature also goes up. So it's kind of that's why it's in layers, because of the temperature differences and what gases are located in those layers. All right, also remember that energy from the sun is what drives our climate here on the Earth, and that happens through the process of convection. Warm moving up and cooling down, and have this cycle. So warm materials rise, colder materials go down. Differences in pressure move the air, and hence the moisture in the air. Changes in temperature will affect the convection currents, and if the convection currents slow down or stop, that is going to affect how much precipitation and temperature is in the area, and therefore it's going to change the climate. That's what climate change is all about, the root of it. So one of the big concerns with air pollution is harmful things that go into the air. So the very definition of pollution is harmful substances entering the atmosphere. So what do we mean by harmful substances? Things that aren't supposed to be there. They're not meant to be there, they're foreign, they are harmful to human and health of organisms on our planet and the environment. So when we burn something like coal, and we take it out of the ground, out of long-term carbon storage where it was intended to be, and we put it into the short-term carbon cycle, into the atmosphere, we're adding chemicals like carbon dioxide, sulfur dioxide, this is a chemistry review, mercury. Particulate matter, PM10, is really tiny particles that are less than 10 micrometers, and that's like 10 to the negative 12th, I believe. So they're very tiny particles that you can easily breathe in, and it can get into your lungs very easily. Heavy metals like chromium, lead, tin, arsenic, and cadmium. How'd you do on your chemistry symbol review? So these particles are in the coal, they're in the ground as the coal's forming, and they become into the atmosphere as we burn it. And when that happens, we get SOx, which means it could be SO, SO2, SO3, SO4. So any of those combinations, that's why this X is here, same with the nitrogen. And they help to form sulfuric acid, carbonic acid, nitric acid. And so that's acid rain. And that is a topic we will talk about in a few days, but obviously you should know a little bit that it's making the water acidic, and we know that it changes the pH, and that affects plants and how they grow and other things in the environment. You can see here sulfur particulates. They deal with your epithelial lining, your colon. You can have colon cancer from taking this in, cancel in your cells, in your inner cells, in your skin cells. Carbon pollutants are going to cause warming, and warming has a lot of different things. Malaria. Greenhouse gases make the temperatures warmer, which breeds mosquitoes, and mosquitoes spread malaria. So that's a big health effect a lot of people don't think about. Carbon monoxide can cause death and lung cancer. It can give you some pulmonary diseases and affect your breathing. And same with the NOxes. It can make asthma attacks happen if you're an asthma person, and it can cause your circulatory system to not work very well. So we've got all this stuff, and yet we keep burning these fossil fuels because we need our energy, but there's a lot of human health effects on the downside of it. So the particulate matter, it has a lot of stress on our cellular levels, and it can contribute to a lot of lung diseases. The heavy metals have a lot of things like lead poisoning, mercury poisoning, arsenic poisoning. They are all poison to our body systems, and so can eventually cause a lot of death and some really weird diseases like Minamata, and a lot of like mental brain diseases, mental retardation, and things like that. So a reminder, we burn coal because we want electricity. So remember the story, we put the supply of coal in, it gets crushed up, it gets lit on fire, ignited to boil some water to spin that turbine to make the generator and give us electricity. But while we're burning the coal, all these particulates are coming out. So we need to think about what we're doing. And there is some good news here. We have some filters. We'll get into what the filters, and we'll talk about those in a couple more lectures of what we've done to try to minimize it. All right, so here's a visual if you like it in a more visually appealing look. So again, NOx can contribute to smog, air pollution. It is a precursor or an ingredient to make ozone, tropospheric ozone. SO2 is the precursor for acid rain. PM10 are those particles, so that's like soot, fly ash, and that can get into our lungs and cause respiratory issues. Black carbon, the black lung disease like the miners get. And then good old smog from burning the coal, and mercury, toxic heavy metals, and like we said, it can affect your nervous system and some brain functions. So when we burn any fossil fuels, we're going to release these NOx, which will react with oxygen and make this ozone. So ozone is considered a secondary pollutant because it had to go through a chemical reaction with something else to form. So things that directly pollute the air and come from a source, those are called primary pollutants. And so primary pollutants combine with other primary pollutants to become secondary pollutants, or more complicated chemical structures. Okay, we can also create things like carbon monoxide, hydrocarbons, and PM, just particulate matter. And the PM we talked a little bit about, there's PM 10 and there's PM 2.5. So this is a little bit larger, but when I say larger, it's still super tiny, and these are super small. And the problem with super small ones is they can get way inside your lungs, into your trachea, way deep down inside, and it can cause harm inside your bodies. Okay, so here's a graphic of how ozone gets formed. Again, ozone, O3, is a secondary pollutant, which means it has to undergo this chemical reaction to form. It doesn't just come out of a tailpipe. So what happens is you've got these NO molecules, nitrogen oxide molecules, and there are these free radical ozones. So oxygens. Usually oxygen is O2, but in a natural oxygen cycle, it will actually break apart to O plus O, and then it's a equilibrium reaction, so it's constantly going back and forth. But what will happen is the nitrogen oxide will get in the way. This oxygen, this free radical oxygen will bind with a diatomic oxygen and we'll get this ozone, this O3 molecule. And then it has a short half-life. I think we looked it up. It was like 14 days, I believe. So it's kind of hanging around for 14 days and then it breaks apart again. And then this NO molecule will bind with that free radical oxygen and become NO2. And then that NO2 reacts with the sunlight and then it breaks apart to make this NO and it just keeps going and going and going. And so that's kind of the ozone forming and disassociating over and over. It's worsened because of what comes out of our tailpipes. Our tailpipes let NO2 come out and then the sun breaks that apart and it frees up NO molecules to make this a worsening product. So it's kind of a positive feedback loop that we don't like. So the more we drive, the more this cycle happens, the more ozone we have as a pollutant ozone, not the good ozone, because this is in the troposphere, not in the stratosphere. So ground ozone is from these chemical reactions between the primary pollutants and sunlight. So it can take, like we were looking at, this NO2 molecule can do this reaction, and also these VOCs. So VOCs are volatile organic compounds. And a VOC, oh, here it is down here, volatile organic compounds. So VOCs come from a lot of things. Gas vapors is a VOC down here, chemical solvents, nail polish, that really strong smell coming out of nail polish is a VOC. That strong smell coming out of your floor cleaner like Pine Sol or Fabuloso, that's a VOC. That strong smell coming out of paint when you just freshly open a can of paint, VOC. So VOCs are in a lot of our industry and things we make and do, and they get out. The gasoline vapors at the car when you're filling up your car for gas, those are VOCs also. So they get out and they mix with the heat of the day and the sun, and the mixture creates this ozone. So it's not naturally, it's forming because of what we're doing, and it is created by these chemical reactions that are man-made chemicals that we're putting into the atmosphere. So ground level ozone health effects. What can it do to us? Well, it makes it hard to breathe deeply. It can hurt when you breathe in. It can give you a sore throat. It makes people wheeze and cough, feel tired. And if you have asthma or emphysema, it doesn't give it to you, but if you have it, it can worsen it and it can make you have really bad days. On the flip side, that little tiny PM10 or PM2.5, kind of similar symptoms. Short dose of breath, it's hard to breathe, your chest hurts, you're tired, and it can not give you, but it can contribute and make worse heart disease, asthma, and COPD. So they're pretty similar in what they can do to each other. Okay, it's kind of important to know the chemical formation. It has been on the test before, just knowing your little reactions of what happens. So remember N2 and O2 exist in the atmosphere naturally. So this naturally happens, this formation of NO, nitric oxide. And then that nitric oxide combines naturally with the naturally occurring ozone, or so I keep saying ozone, oxygen, O2, and it will give us that NO2, two of them. And so that's nitrogen dioxide. So this is all totally naturally occurring. And then the NO2 reacts in the sunlight and we get some NO and a O. So it disassociates this. This is a disassociated reaction. And then that free oxygen will combine with a diatomic oxygen and give us O3. So this happens naturally. This is a normal, natural cycle that happens. The problem is cars put in way more NO2 than what nature does, and so now we have a whole ton of it, and then that gives us lots of ozone. And that is the problem. So it's the anthropogenic effect. Nature was equipped, anthropogenic, to handle some of this ozone cycle, and it's in nature, but not all of it in the amounts of the millions of cars that we have, billions of cars that we have, and are adding this to the atmosphere. Okay, so that was all nitric. Sulfur dioxide is coming from a couple places. Coal and oil burning for fossil fuels, but the oil part is mostly from diesel engines. So if you remember, a lot of you missed this question. When we refine crude oil, it gets separated out by density and we boil it out, fractional distillation, and some of it is gasoline, but the heavier stuff is diesel. And diesel has more components and chemicals in it, and one of the things is this sulfur dioxide. So when the big trucks and diesel trains transport all of our goods and services around the world, they're putting a lot of SO2 into the atmosphere, and SO2 reacts with water, H2O, to give us H2SO4, which is sulfuric acid. It does occur naturally. So when a volcano goes or a geyser out from the ground will go, they do have some sulfur dioxide as well. But again, nature's got a cycle and it was totally fine to handle that and process it. It's the addition of all of our burning of fossil fuels, those anthropogenic additions, that make the problem. And you can see over here, sulfur dioxide comes from a lot of different things. So a lot of chemicals, there's the oil and the gas, cement making, paper factory. We have a paper factory not far from Anaheim High School, so they're putting a little bit of that in our air. So be aware. Okay, this is a video about lead gasoline. I think you guys are too young, but you used to actually have the choice to have leaded or unleaded gas. And leaded gas was for those muscle cars. It would make them go really fast, high octane. It would give them a really big boost. And you could choose to have that, and it would make your car like totally amazing. But then we found out lead was getting into the atmosphere and it was toxic. Lead poisoning became a huge thing. So all you need is 5 parts per million to be affected by that. That's a hard thing for a kid to imagine. If I had a million things in this one box, say there's a million dots in here, you'd only need 5 for that to kill you. 5 out of the million. So a little lead will be very, very toxic. And so we were finding that kids were having all these weird effects because little kids absorb way more of the lead than adults. Their bodies are littler, their hearts beat faster, they circulate things through their body quicker because they have a tinier body and a higher heart rate. And kids put everything in their mouth. So we were having some issues. And the lead-based paint, we had lead in our paint as well. And of course, kids were eating their toys that were painted with lead. Their drinking water, we used to have lead pipes in it. Think of the Flint, Michigan situation. The soil, there's some lead in the soil. Kids eat dirt. Like all this stuff was going on. And then we were burning our gasoline that was putting more lead into the atmosphere. So we, in the 70s, had a big environmental movement, and that's where the EPA was formed, the Environmental Protection Agency. And when that was formed, a whole bunch of laws were passed about the environment. And one of them was the Clean Air Act. And the Clean Air Act said we are no longer going to have leaded gasoline. We're going to have unleaded gasoline. So if you go get gas now, you can see it's unleaded gas. And that's because you used to have a choice, leaded gas or unleaded gas. And we saw this huge drop in the atmosphere. It is still in the soil. It's an element. It can't be broken down any further, but we don't have to be putting it into the air just to drive our cars around. So health effects of lead exposure are awful. It can lead to learning disabilities, behavioral problems. Their bones don't form right. They don't grow well. You can have seizures, comas, death, brain trauma. It's crazy. So wash everything out. Don't let the kids put stuff in their mouth. Make sure that you don't have leaded paint. And for you guys, if your home or apartment was built before 1978, you want to have a lead test and see if the lead has been removed from the paint around your place. Okay, so the cool graph here is we had We didn't really detect lead, but we noticed this spike with gasoline, leaded gas, and lead pipes. And a really interesting um, thing, I guess, is lichen. Remember lichen, the primary pioneer species from Succession? Lichen is really sensitive to air quality, and if there's bad air quality, certain lichens won't grow or they'll look weird. And so it was a way to measure lead levels, and you can make this connection between how the lichen were there or weren't there and how much lead was in the atmosphere. And so this place called Plummer's Island back east, they measured it, and I'm gonna have this stupid pen pointing wrong. Okay, and you can see no lead, no lead. Oh my gosh, lead was coming. Here comes the Clean Air Act, and our lead levels are really low. So that's great. That's a good thing. So that's a good, successful Clean Air Act story. I really like this graphic, and it's something you should like write down on flashcards. The primary pollutants, the things that come straight out of the source. So the sources could be a natural source like a volcano or a geyser. It could be a stationary source like a factory, or there could be mobile sources, anything with transportation that's putting pollution out, but it's not in one place. And so these primary pollutants are coming out straight from these sources, straight from the source. So carbon monoxide, carbon dioxide, the sulfurs, the NOxes, a lot of hydrocarbon combinations, and a lot of the PM particles, the PM10s and the PM2.5s. Comes straight out of the smokestack or out of the volcano or out of the tailpipe. But then they have to react with the sun to become these secondary pollutants. And so most of these are man-made and formed, and they're usually a little bit worse than the primary pollutants. So they're more complicated chemicals. We've got this sulfur trioxide, nitric oxides, nitric acids. I don't know why I said oxides. Sulfuric acid, H2O2 is a peroxide. We've got that ground ozone, PANs. We're going to talk about those in another lecture. And a lot of these salts. So they're all complicated things that lead to really bad air quality. And that's going to be a concern. So know the difference between a primary pollutant and a secondary pollutant, which we will continue in future lectures and get more in depth with. Okay, so this is a video that's going to show you how air pollution circulates through the world. So even if we pollute over here, we might be sending it elsewhere and vice versa. So whatever we do actually affects the whole world because the way wind and air currents work with this convection. So make sure you watch this video. By the end of this video, these are the questions you should be able to answer. Make sure you know the difference between a primary and a secondary pollutant. What chemicals go into the atmosphere from coal combusting and why are they a pollutants? What happens to the atmosphere with the pollutants from fossil fuel burning? What does sulfur dioxide do to the atmosphere? What is the Clean Air Act? When was it happening and why is it successful? So that should get you ready for our air pollution unit, and this is 7.1.